Hello everyone. This video is going to be about literal equations. So we'll be isolating various variables. A literal equation is an equation mostly made up of variables. Letters, right? Letters. That's why it's called literal, because there are more letters than usual. It doesn't have to be all letters, but there are definitely going to be more than one variable. So we will not be able to get a number answer. So we have two examples here. The one on the left should be extremely familiar to you. And the one on the right, we need to solve the equation also for x. Actually, as I look at this, I'm going to go ahead and scroll up so that we'll be able to look at what we've done when we fill in the similarities and differences part. That's probably more for my benefit than yours at this point. All right, so... perfect. So I say at least. All right, so while I was adjusting that, you might have gone ahead and solved the equation on the left, because I know you know how. We could add 5, and then 2x would equal 13 plus 5, which is 18, and then we would divide by 2. So x is equal to 9. Nice and neat, right? Nice and neat. So then the one on the right, we're going to use our problem at the left kind of as a guide. And now we really have to know that we're solving for x, because there are 4 different variables. So this could say for A or for B or for C. It's actually solved for C now because that's the one by itself. So for x, I'm trying to get that x by itself. So just like we did on the left, we'll undo the subtraction by adding. But what's different about that addition step is we can't actually add C and B together because they're not like terms. So the best we can do is just write them next to each other. Then, what did we do before to get rid of the coefficient? This time the coefficient's just a letter. We divide it by that. So, same thing. We're going to divide by A, and then we need to divide this entire side by A. So then this is my answer. Now, that answer could be written in multiple ways. For instance, when I added B and C, I could have chosen to write B plus C. So that answer could also be written as B plus C over A. And then, because they're both being divided by A, I could really write that in 2 separate fractions if I chose, and there'll be times when that's appropriate. I could write C over A plus B over A. Or, again, it could have been switched up and be B over A plus C over A. Please know you are not required to give me all of those, but I do want to acknowledge and point out that there are multiple ways that all mean the same thing. It would not mean the same thing if I put B over A plus C and C not in a fraction. Okay, so it doesn't mean that just any old way, if I put the B on the bottom instead of the C on the bottom. No, the A has to be on the bottom. So it's not just any way, but there are multiple ways to write it. So sometimes, like if you're checking your work with my packet, yours may not look exactly like mine. So before you just erase or assume you have it wrong, please ask, or if you're checking with a classmate, it could be that both of your answers are correct. All right, so now let's look about what was the same, similarities, things that are the same, and what is different. What are the differences between these two equations? So one similarity, I'm just going to label S for similarity. One similarity is both had subtraction, right, in the original equation. Both had subtraction. So we solve with addition. So I can make that a nice capital letter. Another similarity both had multiplication. That we solve with division. So kind of maybe that's almost 4 similarities. So let's think about then what is different, right? What's different? The answers look very different, right? So what's different? A difference is that in the literal equation, we can't simplify, right? We can't just do the math. So I could have written the other one as 13 plus 5 all over 2, right? So keep in mind that this answer means the same as if I wrote but we wouldn't leave it that way. We simplify it, and we simplify it along the way. And so that brings us to another difference, is that the answer is not a number. In the literal equation. Instead, it's an expression. So really, in the literal equation, you can think of it as you're just rearranging the variables. So hopefully you notice that the process, the steps we have to take to undo things are the same as an equation. So if you kind of look at these and think about what would I do if this was a number, if everything were numbers except the variable I'm solving for, how would I operate? And then just go ahead and take those steps. Just know that your final answer is not going to be simplified, so it won't be a number. There may be some numbers involved, but you won't just be able to get a final answer like we can with a traditional equation. All right, so let's move on down here and try some others. The first ones here are just one step on the bottom of your page here. These are just one step, and most of these are formulas. And so you might be familiar with these formulas from another class, but the beauty of it is even if you've never seen the formulas, some of you know that this first one is L times W for length times width. Some of you might have thought that was a 1. I'd really like to use a capital L instead because of that. But whether you know that that is symbolizing length times width and area, it doesn't matter. There are some formulas that I don't know what the letters are supposed to represent, or they might be physics equations. I can solve for a particular variable without being a physicist. So please don't think that you have to understand what the formulas are. Now, if we were using the formulas, yes, that would be important. But you can manipulate the formulas regardless of if you know what each letter represents. Just know which one you're solving for and work to get it by itself. So you always want to think, first, there's not an X at all, so we have to think, what are we trying to get by itself? So in this case, we are trying to get W by itself. So the one that you're trying to get by itself, think of him being kind of like tied down. Leave that one where it is. And you want to remove the other variable from that side. So you need to ask yourself, what is currently happening between L and W? Well, currently, L and W are multiplying. And so if they're currently multiplying, to undo that, we need to divide. So we will divide both sides by L. I'll try to make it a little cursive-y L so it looks more like an L instead of a 1. I should just probably make it capital. And so then I have A over L is equal to W. And that's all, because this is just one step, just like if those were numbers. And so since it's just one step, there's really not like a lot of ways to write that. That's it. So if it starts out with multiplication, like these problems here primarily are multiplication, then we're going to divide to solve. So I'm going to work down to number 3. So if I want to solve for t, that means we're leaving t alone, so I need to get rid of r. So I'll divide it because they're currently multiplying. Whatever I do to one side, I have to do to the other. Then I have d divided by r is equal to t. This is actually distance, rate, and time. You might have 3 variables being multiplied, like in number 4. Interest equal principal times rate times time, simple interest formula. So, but they're all squished together, so they're all being multiplied. So if I want t by itself, I need to get rid of both p and r. They're all being multiplied together. So in one step, no point in doing it in 2, we can just divide by both p and r. Sometimes people are like, I don't know how to know when I'm finished because, it doesn't look finished. Well, if your variable that you're solving for is by itself, you're finished. Occasionally, we might have something that we could simplify a little bit, like reduce a fraction or something, but typically, once you get that variable by itself, that's how you know you're done. All right, so number 5, go ahead and try number 5. It is very much like number 4, so try number 5. So hopefully you came up with V over, I'm going to go ahead and make the L a capital, LW is equal to H. So I'd have to divide by both of those. Once you get the hang of these, in a lot of ways they're actually a little bit easier because there's no worries about doing the arithmetic wrong. So in number 7, we finally have something besides multiplication. If I want C by itself, I can add S to get rid of minus S, and then have M plus S is equal to C. In number 8, I'm trying to get M by itself. It's currently being divided by V, so I need to multiply to cancel out division. So I have dV is equal to M, or you could write VD is equal to M, right? Because when I'm multiplying, the order doesn't make a difference. I could write a dot in between them, but it's not necessary. If we write them mashed up against each other, it does show that they're multiplying. So we'll go to the next page and do a few more examples. And then I'm going to do some examples on the left-hand column on the next page. And then I will just ask that you finish 10 through 14, so just 3 problems, 10, 12, 14. We'll have a few opportunities to review this again. So won't be a homework assignment that I actually ask you to turn into me, but in class I will be asking that you work some of those on your own. And wow, this page is a bit on the tilted side. Things did not get pulled into the copier very straight. It's so much more obvious on the screen. I guess on paper I just tilt my paper. All right, so here if I'm solving for H, so if we have fractions, we're going to want to multiply, but by whatever base. It says the reciprocal. Oftentimes it's just like whatever's in the denominator. Get rid of those fractions first. So I see a 2 in the denominator, so 1/2. So the reciprocal of 1/2 is 2. So we're going to multiply by 2. So if I multiply both sides by 2, that's clearing the fractions. That's what we're doing there. So these 2's cancel. I have 2a is equal to, then this would just be bh. I could write 1bh, but it's not necessary. And then I need to get rid of the b, because remember h is the one we're solving for. So divide both sides by b. So 2a over b is equal to h. So pretty similar process for your problem for number 10. For number 11, we are solving for m. Remember, there's multiple variables. The same problem could say solve for v. So we have to always pay close attention to which one am I supposed to get by itself. So in 11, I'm supposed to get m by itself. So I'm going to multiply both sides by 2. On the right, that gets rid of the fraction. On the left, I now have 2k. And since I want m by itself, I can divide by v to the second, v squared. I don't need to worry about square rooting or anything because the square wasn't on the m, it was on the v. So I can just move that whole thing as one piece. And then there's my answer. All right. And in number 13, we are solving for W. We could also have been asked to solve for L. The process would be very similar. So if I'm solving for W, I want to get rid of these L's. I need to get the L out of there. So I'm going to subtract 2L on both sides. That makes that go away. Now I have P subtract 2L is equal to 2W. Divide both sides by 2. And then it would be acceptable to leave my answer as P minus 2L over 2. It would be also acceptable to say P over 2 minus L is equal to W. Because if I split it into two fractions, then the 2 could cancel out, that's with the L. But the P doesn't have a 2, so it is stuck with a fraction underneath, making that it's part of a fraction. All right, so I hope those were some helpful examples. Again, if you were in pre-algebra, this is review. But if it's been a hot minute and this is one of the topics that typically gives people a little bit of trouble, then you may have some questions, so I wanted to at least refresh this for everyone. All right, thanks.